Now I'm going to talk about the critical consistency, which I mentioned that in the previous video. Well, if the designer, for example, designed that system for you in virgin fibers, softwood or hardwood, but you are running now with different furnish and so on, as I mentioned, that require also some design criteria. And in brief, I'm trying to explain a little bit more details because of that complexity of that area. If you really picture a sphere, and the sphere has a diameter, and if you picture further, the diameter of that sphere is the length of the fiber. And of course, we should know what that length of the fiber is. Different between softwood and hardwood, and also within the hardwoods and softwood if you want to be more specific. Sometimes in specialty grades we have flax fibers, alpacas and that kind of things, and tea bags, they use these long fibers. You can see the fiber has a length and a diameter. The relationship between the length and the diameter, we call it aspect ratio or slenderness ratio. All these informations are readily available. They are morphological terms in the fiber type. You can see when that fiber rotates in that field, it's going to be entangled with other fibers like that. Some of these entanglement can be more or less. Scientists were able to find out that if you have more than 3 contacts, you see that like that cross fingers over here, you end up with more flocculation. And we call that, more than 3 contacts, the critical consistency. You are welcome to run at or lower than the critical value, but not higher or terribly higher than the critical value. You can see over here in that picture, you have normal forces, friction forces. Once these fibers are flocculated with each other entangled, you simply will not able to break it up. And no matter what you do downstream of the head box or the wire table and so on, then these fibers will not be able to break it up. So you have to start from a good design based on the furnish type what you have. From that, then you can determine what kind of flow rate you require, what kind of production, of course, you need to produce, first pass retention and so on. Then you design your head box and approach piping area. And these are the kind of details which Papyrus perform and find out where the bottlenecks are, where the problems are, and make the proper recommendation.